It sets out to do something that sounds simple and turns out to be hard. To look at the cosmos as human beings have actually understood it, through measurement, through inference, and through meaning, and to keep those three kinds of knowing clearly apart. Astronomy is the foundation of this book. It is the oldest of the exact sciences, and every cosmology, ancient or modern, is built on what the sky has been observed to do. Astrology, by contrast, is treated here as a historical, symbolic, and cultural tradition, not as established science. Myth and religion are treated as cosmological meaning systems, serious human answers to the question of what the universe is for, which is a different question from what it is made of. And the contested scientific frameworks this book examines, plasma cosmology, electric universe claims, steady state and cyclic models, are presented as exactly that, contested. The mainstream model is given a full and honest hearing before any challenge to it is raised. To keep faith with the reader, the book holds to three registers and labels them as it goes. The first is measurement, what has actually been observed, counted, timed, or photographed. The second is inference, what we conclude from those measurements by way of a theory, which is only as good as the theory. The third is interpretation, the symbolic, philosophical, and metaphysical meaning that human beings have read into the sky. Much confusion in popular cosmology comes from mistaking one of these for another, treating an interpretation as a measurement or a plausible inference as a proven fact. Wherever there is a real debate, this book will tell you so, and will try to show you both sides well enough that you could argue either one. The result is not a verdict handed down, but a quest laid out, the cosmology of our universe as a set of competing accounts tested against the same sky. Introduction. A few plain facts frame everything that follows, and it helps to have them in view from the start. The sun is not standing still. It moves through the Milky Way, carrying the planets with it, so the solar system is a single traveling structure rather than a fixed backdrop with wanderers looping around a stationary center. Earth, meanwhile, wobbles. Its axis slowly traces a circle in the sky over roughly 26,000 years, a motion called precession. The Great Year and the astrological ages are interpretive frameworks built on that real wobble. The astronomy is measured, the ages are read into it. Ancient traditions such as the Maya long count and the Vedic Yuga cycles encoded long spans of time in their own ways, sometimes strikingly, sometimes in ways that later readers have overstated. This book will present both sides of the argument wherever there is a genuine debate, not to be evasive, but because the honest state of the question often is two-sided. Where the science is settled, it will say so. Where it is not, it will say that too. Astronomy did not begin as a search for the meaning of the universe. It began as a set of supremely practical problems, and it took hold because the sky was the most reliable thing in the world. Everything on Earth was uncertain: the hunt, the harvest, the weather, the movement of enemies and game. But the sun rose, the moon filled and emptied, and the stars wheeled overhead in a pattern that repeated with a regularity nothing on the ground could match. A people who learned to read that pattern gained something close to prophecy, the ability to know in advance when the seasons would turn. The oldest surviving evidence of that skill is startlingly early. At Warren Field, near Craiths in Aberdeenshire, Scotland, a row of 12 pits was dug into the ground by hunter-gatherers roughly 10,000 years ago, around 8000 BCE. When archaeologists, led by Vincent Gaffney, analyzed the alignment, they concluded that the pits appear to track the phases of the moon across a year and to line up, at one end, with the point on the horizon where the sun rises at the midwinter solstice, a built-in correction that would let the lunar count be reset against the solar year. If that reading is right, Warren Field is a kind of calendar, and it predates the first calendars of the ancient Near East by nearly 5,000 years. It was made by people who had not yet invented farming in that part of the world, let alone writing. The urge to keep time by the sky, in other words, is older than civilization itself. Timekeeping was the first use, and for most of history, it was the most important one. A calendar is not a convenience. For an agricultural society, it is the difference between eating and starving. Plant too early and a late frost kills the seed. Plant too late and the crop does not ripen before the cold returns. The sky solved this problem with a technique used independently all over the world. The heliacal rising, the first morning on which a given star becomes visible just before sunrise after a season lost in the sun's glare. In Egypt, the heliacal rising of Sirius, the brightest star in the sky, came at almost the same time each year as the annual flooding of the Nile, and the two events together anchored the Egyptian calendar. The Greek poet Hesiod, writing his Farmer's Almanac around 700 BCE, told his readers to harvest when the Pleiades rose and to plow when they set. The stars were a clock that everyone could see and no one could stop. The moon was almost everywhere the first timekeeper because it is the sky's most obvious clock. It changes shape night by night and completes its cycle in a span short enough to count on one's fingers across a month. Cultures from Mesopotamia to Polynesia built their months directly on the lunar round, and the word month still carries the moon inside it. But the moon and the sun keep different time, and reconciling them is the central problem of every calendar. 12 lunar months fall about 11 days short of the solar year, so a purely lunar calendar slides steadily backward through the seasons, its festivals wandering out of step with the harvest. Deciding when to insert an extra month to haul the lunar count back into line with the sun drove some of the earliest sustained astronomical record-keeping, and it is a problem the world's calendars go on quietly solving to this day. The second great use was navigation. On land, a traveler has landmarks. At sea or in a featureless desert, the only fixed points are in the sky. The North Star sits nearly above the Earth's axis and so barely moves through the night, giving a steady bearing to anyone in the northern hemisphere who can find it. The Polynesian wayfinders who settled the vast triangle of the Pacific, thousands of miles of open ocean from Hawaii to New Zealand to Easter Island, did so without instruments, holding their course by memorizing the rising and setting points of dozens of stars along the horizon and reading the swell of the sea beneath the hull. Their star compass was carried entirely in the mind, and it was accurate enough to find specks of land in an ocean that covers a third of the planet. That, too, is astronomy, measurement in the service of getting somewhere and coming home. The division of time ran finer than the year and the month. The Egyptians split the night itself into hours by watching a sequence of stars called decans rise in succession, so that the appearance of a particular star announced a particular hour, a stellar clock for the dark. By day, the same civilization and many others measured the passing hours by the flow of water through a marked vessel, the water clock checking the sky against the machine and the machine against the sky. Long before the mechanical clock, then, human beings already possessed the two ideas at the heart of all timekeeping: a repeating natural cycle to count and a steady artificial process to divide the intervals between. Eclipses show how far the predictive power could reach. A total eclipse of the sun is among the most frightening things the sky can do. The day darkens, the stars appear, the sun becomes a black disk ringed with fire, and for most of history it arrived without warning. Yet the Babylonian astronomers, by keeping records over centuries, discovered that eclipses recur in a rhythm now called the Saros, a cycle of about 18 years and 11 days, after which the geometry of sun, moon, and earth very nearly repeats. Once you know the Saros, you can say when an eclipse is likely, and a sky watcher who can predict the disappearance of the sun holds a formidable kind of authority. The practical arts of watching, counting, and remembering had, by this point, become something more, a system that could reach into the future.